Hello everyone, myself Shruvangi Desai, your instructor for the video series of Data Mining and Business Intelligence. Today's our topic is Improved Apriori Algorithm. So let's get started. Before understanding the Improved Apriori Algorithm, we first need to discuss limitations of Apriori Algorithm, which are time and space complexity and low performance. First, as a priori algorithm tends to create multiple candidate item set in order to find out a frequent item set, it requires a huge amount of time and space. Second, in order to create multiple candidate item set, it has to scan the whole database for multiple times, which ultimately reduces the performance of the a priori algorithm. Now, how to enhance the efficiency of a priori algorithm? In order to improve the efficiency of the a priori algorithm, we have multiple methods. Methods like hash-based technique, transaction reduction, partitioning, sampling, and dynamic item set counting. So let's start with hash-based technique. A hash-based technique can be used to reduce the size of the candidate k item set, that is Ck, for k greater than 1. For example, when scanning each transaction in the database to generate the frequent 1 item set, that is L1, we can generate all the 2 item set for each transaction, hash them into the different buckets of a hash table structure and increase the corresponding bucket counts. A 2 item set with a corresponding bucket count in the hash table, that is below the support threshold, can be frequent and thus should be removed from the candidate set. Such a hash-based technique may subsequently reduces the number of candidate k item set examined, specifically when k is equal to 2. Now let's understand this technique using an example. As you can see, we have a reference of a transaction table from all electronics branch, and in the below image we have created a hash table. H2 is a hash table which is generated by scanning the transaction table while determining L1. If you can see that the minimum support count is, say for example 3, then the item set in the bucket 0, 1, 3 and 4 cannot be frequent and so they should not be included in seed. Next is transaction reduction. A transaction that does not contain frequent k item set cannot contain any frequent k plus 1 item set. Therefore, such a transaction can be marked or removed from further consideration because subsequent database scan for j item set where j greater than k will not to consider such a transaction. Let's understand this concept using an example. As you can see in this figure, it shows the transactions of all electronic branch. There are a total of 9 transactions with the associated items. If you can notice that in transaction T2 there are 2 items, I2 and I4. Now assuming that the support count, minimum support count of this example is 3. So item I2 and I4, that is of transaction 2's item, is having a support count of 2 only, which means it does not satisfy the requirement of minimum support count. So this transaction should be marked or removed from the further processing. Next method is partitioning. Partitioning technique can be used that requires just 2 database scan to mine the required frequent item set. So let's understand how it works. As you can see in this figure, the whole processing of partitioning method is divided into 2 phases. It requires only 2 database scan in order to find out the frequent item set. In first phase, the transactions of database D is divided into n non-overlapping partitions. Then after, it find out the local frequent item set from each of the partitions. Now what is local frequent item set? These are the item set which are frequent in that particular partition. Once all the local item set are mined, then after they all are combined together in order to form a candidate item set, or we can say a global candidate item set in order to find out the global frequent item set. So in phase 2, again a database D is scanned in order to find out a global frequent item set from the combined candidate item set. Next method is sampling. The basic idea of the sampling approach is to pick a random sample S of the given database D and then search for frequent item set in sample S instead of the entire database D. So ultimately, using sampling method, we are trading off some degree of accuracy against efficiency. Now, when we are using a sample S in order to find out the frequent item set instead of D, it requires only a single scan as the size of S is much smaller compared to database D. But while we are finding out the frequent item set from S rather than D, we might tends to eliminate some of the frequent item set that may appear in database D. Now, to reduce the possibility of this, we uses a lower support threshold than minimum support to find the frequent item set which is local to S. The rest of the database is then used to compute the actual frequencies of each item set in L of S. A mechanism is used to determine whether all the global frequent item set are included in L of S or not. If L of S actually contains all the frequent item set in database D, then only one scan of D is required. Otherwise, a second pass can be done to find the frequent item set that were missed in the first pass. So this is how sampling method works. Last method is dynamic item set counting. In dynamic item set counting, database is partitioned into blocks and marked by start points. New candidate item set can be added at any start point, unlike in Apriori algorithm, which determines new candidate item sets only immediately before each complete database scan. This technique uses the count so far as the lower bound of the actual point. If the count so far passes the minimum support, the item set is added into the frequent item set collection and can be used to generate longer candidates. This leads to fewer database scans than with Apriori for finding all the frequent item set. That's it for this lecture. Thank you.